guys, and welcome to BNU1501 class. Today is our second class, which are going to cover more important and significant concepts of mathematics covered in BNU1501. Okay, we're going to look at question number 1, and I'll be explaining all the concepts and how you need to remember them. Some of the concepts that we're going to talk about, they just establish the basis of you understanding the mathematical concepts. But I'll also reiterate on the parts that you need to remember very carefully when it comes to the exam. On question number 1, they gave us a fraction. So when you're dealing with fractions, there are 3 basic types of fractions. There are an improper fraction, there's an improper fraction, there is a proper fraction, then there is a mixed fraction. So an improper fraction is when we have, for example, 7 over 2. A proper fraction is when we have, say, 3 over 5. And a mixed fraction is when we have 3 and 5 over 6. So these are the examples of fraction that we have: an improper fraction, a proper fraction, and a mixed fraction. So on our question number 1, they gave us a mixed fraction, to which they said write 3 and 5 over 6 as an improper fraction. That means we need to move from a mixed fraction to an improper fraction. If we are doing that, what we need to remember is 3 is a whole number followed by 5 over 6. So when we are moving from a mixed fraction to an improper fraction, what we need to remember is we need to say 3 times 5 times 6 plus 5. So we say 3 times 6 plus 5 over 6. Then we get our answer. That means if we say 3 times 6 plus 5, it will give us 23 divided by 6. That's our improper fraction. So when you're moving from a mixed fraction and improper fraction, that's what you do. You say the whole number multiplied by the denominator plus the numerator. Same applies if you are moving from an improper fraction to a mixed fraction. You say 6 into 23. 6 into 23 gets 3 times. Remainder 5 over 6. But 6 times 3, it's 18. 18 from 23, it gives you 5 remaining, then 5 over 6. So those are the types of fraction that we'll be dealing with. They don't usually ask this in the exam. They just give you to establish the basis of understanding the fractions. Now, on question 2, they also give us an improper fraction. And our improper fraction is 29 over 8. They wanted us to change it into a mixed fraction. So to change an improper fraction to a mixed fraction, we say 8 into 29. 8 into 29 gets how many times? 3 times. And how many do we'll be left with? So say 8, 16, 24. Then we'll be left with 5. Then we will remain 5 over 8. Over 8. That's how we change that. Then moving further, so those are basically the concept that we need to remember when it comes to fraction. Then we need to introduce a concept of lowest common multiple, LCM. Lowest common multiple. Lowest common multiple, LCM. Lowest common multiple, we're looking for a number that all the numbers we are given can get into that number without leaving a remainder. For example, we are told that we have 4AB And we are also given 6a squared b squared. And then we have 14a squared b cubed. So we need a number that 4, 6, and 14 can get into that number without leaving a remainder, each individually. So usually they will give you the numbers already determined, because the calculation or the determination of this lowest common multiple is a long method. So what you do, you look for the given numbers. First and foremost, the best easiest way is to start with the biggest number, which is 14. So if you say 14 times 2, it will give you 18. Then it will give you 28. Then you check if 6 and 4 gets into 28 without leaving a remainder. No, because 6 cannot get into 28. Then you move on to multiplying 14 by 3 by 4 until you get the number that 6 and 4 and 14 gets into that number. So without having to go through that long process, you just check on the answers that are given. To check, we only have 84 that we have. So you check if 14 gets into 84, 6 gets into 84, and 4 gets into 84. Then eventually you see that 4, 6, and 8 can get into 84. Then our lowest common multiple is 84. Then when it comes to variables, if you are looking for the lowest common multiple of variables, you just get the variable with the highest exponent. So A has got the highest exponent of 2 and the B has got the highest exponent of 3. So this will be your lowest common multiple for these three numbers that are given. Let me simplify it. If you are given, say for example, the lowest common multiple between 3 and 7. In other words, you need a number that in the multiples of 7, in the multiples of 3, you get both they can get into. We know that if you say 7 times 2, it gives you 14, but 3 cannot get into 14. But if you say 7 times 3, which is 21, we know that 7 can get into 21, 3 can get into 21. So our lowest common multiple will be 21. Okay. Then moving on, usually they will ask this question in the exam, and when they ask it in the exam, they'll ask it like the example that we just did here. Say what is the lowest common multiple. So if you are asking the lowest common multiple given this scenario, you look for the lowest common multiple for the numbers first, then you move on to variables, and when you're dealing with variables, just get the one with the highest exponent. So let's use another example on question number 4, which says 7s to the power 4 and 2s t and 4t squared. So what is the lowest common multiple of these numbers? So the lowest common multiple, we now need to deal with the numbers 7, 2, and 4. So we need a number that 7 and 2 and 4 can get into that number. To which we say, if you're in the exam, you just choose the one that you want to start with. 14, we know that 7 can get into 14, 2 can get into, but 10 cannot get into 14. Then 14 is not the ideal number. Then 28. 7 can get into 28, 2 can get into 28, and 4 can get into 28. So our lowest common multiple in terms of numbers is 28. Then after 28, remember what we said when it comes to variables. We just take the variable with the highest exponent. That is what we use. So the variable with the highest exponent in terms of s to the power 4 and t to the power 2. Then you will be done. Moving further, we also come across questions where we need to simplify an expression which is multiplying, which are laws of indices. For example, we are given an expression here which says 2 open bracket x y close bracket to the power 2 over 8x to the power 3. So when you are given an expression like this, you need to apply what you call laws of indices. And laws of indices mention that we have to multiply exponent by exponent, and then we apply the rules that I'm going to explain soon. Here we have an exponent of 2, but we know that inside the bracket we have x to the power 1 and y to the power 1. Why am I saying so? Because we have a rule that says any number raised to the power 1 is itself. For example, if we say 2 to the power 1, it will give us 2. If we say x to the power 1, it will give us x. So when they write these numbers or variables, they don't include the to the power 1. But we are going to include them in our calculation so that it makes sense what we are about to explain now. Now, we are going to say 2 times 1, it gives us 2. 2 times 1 gives us 2. So our answer will be 2 open bracket x to the power 2 y to the power 2 close bracket divided by 8x to the power 3. Then moving further, now we need to get rid of the bracket. To get rid of the bracket, we will multiply 2 with everything inside the bracket. That means it's going to be 2x to the power 2 y to the power 2 over 8x to the power 3. Once you're done with that, can you see that they are dividing? So if you are dividing exponents, the numbers you divide them as normal. 2 into 2 is 1, into 8 is 4. But when you are dealing now with the variables and exponents, you subtract. If you are dividing exponents, if the bases are the same, you subtract. So here we are going to say x to the power 3. So we're going to say 3 minus 2, which will give us 1. So here it will be 1. Here we'll be left with only 1x. Right? And then that's it. So our final answer will be y to the power 2 over 4x. Because underneath we don't have any y to divide or subtract with. So you need to follow those simple steps to get your answer correctly. Okay. Moving further, we also have to deal with fractions. We have looked at fractions in our previous lessons, but we are going to also re-emphasize on the fractions as we go by. Now we are given an expression in terms of fractions that they want us to simplify. And remember, we said when I say simplify, they're saying as simple as possible, but still meaning the same thing. So here we have 4 over 9 minus 2 over 3 plus half. So if you have a calculator, you can just punch all of it together once, there won't be a problem. But according to this question, we don't need to do that. We need to look for a common denominator between these. So our common denominator, which is the lowest common multiple, that is for 9, 3, and 2, will be 18. We know that 2 can get into 18, 3 can get into 18, and 9 can get into 18. So now we are going to say 9 into 18. It gets there twice. So we're going to say 2 by 4, the numerator. Then we go to the next part, we say 3 into 18. It gets how many times? 3 into 18, it gets there 6 times. Remember? So minus 6 times the numerator, 2, plus 2 into 18, 9, multiplied by the numerator, 1. Then once we have done that, the next step that we're going to look at is we're just now solving. 2 times 4, that's 8, minus 6 times 2, that's 12, plus 9 over 18. Then our final answer will be 5 over 18. Then we'll be done. So when you're dealing with fractions, and those fractions are adding and subtracting, you look for a common denominator. That's the most important thing. Whenever you're dealing with fractions, if the fractions are adding and subtracting, you look for a common denominator. Whenever you're adding or subtracting fractions. Okay, moving on, we have another fraction, type of fraction that we don't need to look for a common denominator. Usually, they will be asking you to multiply and divide a fraction. So if the fraction is multiplying and dividing, you don't look for a common denominator, you just multiply as it is. But you have to apply one rule that is very important that you need to remember. For example, here we are faced with a fraction which says 2 over 5 divided by 4 over 5 times 1 over 6. So when you're given a fraction like this, you don't look for a common denominator. What you do is to change this division into multiplication. How do you do that? You will then say 2 over 5 multiplied by, then you exchange the numerator with the denominator. Hence, you're going to say 5 over 4 multiplied by 1 over 6. Then you are warm and dry. Then from there, you multiply 2 times 5 times 1. You get what? 10. Once you get your 10, that's what we have, over 5 times 4 times 6, which is what? 120. Then you can divide 10 into 10, it's 1 into 20, it's 120, it's 12. So your final answer will be 1 over 12. So when I given a fraction where they are multiplying and dividing, you just change on the division part. The second fraction is what you convert. You exchange between the numerator and the denominator. Then you change the sign to multiplication. Then you multiply as it is. Then you will be warm and dry. Okay. But we also have other scenarios where the fraction indicates both multiplying and addition, or multiplying and subtraction, or dividing and subtraction. How do you go about that? That one is very simple. We will apply what we call BODMAS in terms of priority. How do we do that? For example, we have a question here which says 5 over 6 plus 11 over 3 times 1 over 4. So what we do, we first have to multiply the multiplying fraction, which is 11 times 1, which gives us 11, over 3 times 4, which will give us 12. Then we will bring down this fraction, which is 5 over 6 plus. Now, because the fraction is adding, we look for a common denominator, which is the lowest common multiple between 6 and 12, which is 12. Then we say 6 into 12, it gets twice. And say 2 times 5 plus 12 into 12, it gets only once. 1 multiplied by 11. Then from there, we then say 2 times 5, which is 10, plus 1 times 11, which is 11 over 12. So our final answer will be 21 over 12. Then we are warm and dry. 21 over 12. So we would have simplified a fraction like that. So whenever you have a fraction which has multiplication and addition, you first deal with the multiplication part, then you deal with the addition part. If it's subtraction and division, you deal with the division first by remembering to change the sign from division to multiplication and then convert one of the fractions. Then you multiply, then you are good to go. So after fractions, these are basically simple fractions where you just deal with numbers. And in most cases, you can just use your calculator. However, the reason why we have to emphasize and explain the steps is for you to be able to answer some of the fractions that comes with variables, such as the one that we are about to answer now. Question number 9 goes as follows. 3 over 2x to the power 3 plus 1 and x to the power 2. This is a fraction, but it has exponents. You cannot punch it directly into the calculator. You need to know the steps that you need to take. So you look for a common denominator, which is the lowest common multiple between 2x to the power 3 and x to the power 2. Remember, lowest common multiple between these two is here is as good as there's 1 here. So we know that 2 can get into 2 once and 1 can get into 2 twice. So our common denominator in terms of the number is 2. Then we said whenever you're looking for a lowest common multiple of a variable, you just take the variable with the highest exponent, which is x to the power 3. So this is our lowest common multiple of these two numbers. Once we have this, we then need to move on to apply the concept. 2x to the power 3 into 2x to the power 3 gets once. So it's only 1 times 3 plus 1x squared into 2x squared gets how many times? 1 into 2 is 2. And then we'll be left with x to the power 3. Then remember, x to the power 2 into this, it will get how many times? 2x. So it will be 2x times 1. Then, after that, 1 times 3, it will give us 3, plus 2x times 1 is 2x over 2x to the power 3. From here, you cannot go any further because these are unlike terms. You cannot add them. So basically, you need to remember how to go about these steps. And remember how I got my 2x here. We agreed that we said x squared into 2x squared. It gets twice. Right? So we are going to say 1 into 2 is 2. Then x, we have exponents, which is 3 and 2 and 3. So I'm going to say 3 minus 2 gives us 1. So it's 2x to the power 1, which is as good as 2x. Then we are warm and dry on that part. So that's how we answer question number 9 as part of our fractions. So when you're dealing with fractions, you've got only 3 basic fractions that you expect to get in the exam. The one where you're adding and subtracting. The other one when you're multiplying and dividing. The third one is when you have variables, which you need to include in your calculation. Okay. Now, explaining further in terms of expressions, we need to deal with expressions, right? We also have expressions given on question number 10, which says 2b squared, open bracket, a minus 1, close bracket, minus 8a, open bracket, b squared, plus 1. When you are given such expression and they say can also be written as, in other words, they are saying simplify. So when you are simplifying an expression, remember we said you remove brackets first. So you say 2b squared times a is going to give you 2ab squared minus 2b squared times 1, 2b squared. Then minus 8a times b squared. It gives you what? Minus 8ab squared. Then minus 8 times 1. Minus 8 times 1. It will give you minus 8a. Then after that, we group like terms, similar to items. So we're going to say 2ab squared minus 8ab squared minus 2b squared minus 8a. Which then goes further to say 2ab squared minus 8ab squared. It gives us minus 6ab squared minus 2b squared minus 8a. So this can be rewritten as that. So this can be written as that by following those steps. Okay, so those are the elements that we also need to remember in mathematics, especially for BNU 1501. We need to remember those elements to be able to answer exam questions. On question 11, we are given a fraction, and that fraction, they say it's a mixed fraction. It's 2 and 5 over 8 as a decimal number. So if you want to write a mixed fraction as a decimal number, we first need to convert that fraction into an improper fraction. So we said to convert a mixed fraction to a proper fraction, we say 2 times 8 plus 5 divided by 8, which will give us so the fraction is 2 and 5 over 8 as a decimal, right? So as a decimal, 2 and 5 over 8. So we're going to say 2 times 8 plus 5, which is what? 21. So having 21 over 8. Now this is an improper fraction. Now we need to move further from being improper to a decimal. So when you're changing an improper fraction into a decimal, you say 8 into 21, it only gets in twice. Remainder 5. Because you say 8 times 2 is 16, remainder 21 is 5. So remainder 5, and we add a 0. So 8 into 50, it gives us what? 6. Remainder 2. Then that remainder 2, we add a 0, which makes it 20. Then we will say 8 into 20. 8 into 20, it gets how many times? Twice. Remainder 4. And that 4, we add a 0. Then you say 8 into 40, it gets to 5. So our actual answer in decimal is 2,625. But the question says to 2 decimal digits. So the 2 decimal digits, that means we need to only 2 after the comma. So we are going to say 2 comma. We can see that the next number 5 is between 5 to 9. So we add 1 on the 2 to make it 6, 3. That will be our final answer. That's how we convert a mixed fraction into decimal. Okay, going further, question number 12, they are asking us to write 0.375 as an ordinary fraction. So 0.375 as an ordinary fraction. What you need to do is to look at the numbers after the comma. How many numbers after the comma? So you say multiplied by 1. Then that 1, you need to add zeros after the 1. To know how many zeros to add, you look for how many numbers after the comma, which is 1, 2, and 3. So you add 3 zeros here. That means you are going to multiply by 1,000. So if you multiply 0.375 times 1,000, it gives you 375 divided by 1,000 to make it a fraction. Right? Then you can simplify this fraction. To simplify this fraction, you need to look for a number that gets into 375 and 1,000 without leaving a remainder. And that number, the biggest number that can get into both the numbers is 125. So 125 into 375, it gets 3 times. Into 1,000, it gets how many times? 8 times. If you are to go further. But if the answer that they are looking for is just ending here, then you can end it there. Okay. Now, we can go further. On question number 13, we need also to look for other examples in relation to ratios. Sometimes they will give you a ratio. How do we formulate a ratio? On our previous class, we learned that when you are dealing with a ratio, we need to add them. When you need to divide a ratio or sharing a ratio. But on this instance, we need to formulate a ratio. How do we formulate a ratio? So when you're formulating a ratio, they told us that a picture is 60 centimeters wide and 1 meter long. So it's 60 centimeters wide and 1 meter long. But now you can see that here it's in centimeters, here it's in meters. So what we need also to learn is how do these relate, the meters to centimeters? We know that with our guidelines, we need to remember that for every 100 centimeters is equivalent to 1 meter. So meaning to say, for us to have 1 meter is as good as 100 centimeters. Therefore, 60 centimeters So we can say now that 60 centimeters is to 100 centimeters. Therefore, we just need to reduce these numbers as further as possible. So we can look at the number that gets into 60 and 100 without leaving a remainder. And that number can be 10. That's the maximum. Or 20. Or whichever. Because if you use 20, we can say 20 into 60 is 3, and into 100 is 5. But we don't have that on our ratios here. But if you use 10, we can then now say 60 S to 100. So 10 into 60 is 6. Into 100 is 10. Which is the answer that we get. So whichever way, even if you use this or use that, one way or the other is still the same, but it depends also with the answer that they're looking for. In this instance, they wanted to divide by 10. Okay. So having said that, that is very important. We need to remember how to go about this. Okay. And other concepts that you need to look out for too is the way to deal with the VAT. They just ask you those areas just to see how mathematically equipped are you when you deal with VAT and so on. So like question 14, they asked you to say, Jeff is about to buy a vlogging camera that cost 8,500 excluding VAT. That means 8,500 does not have VAT in it. We assume that VAT is 14%. The Digistore offers an 8% discount if he pays in cash. So now you need to know how to deal with percentages, right? How much will he save if he buys the camera in cash? So first of all, when you're buying an item, you buy it including VAT. So you need to include VAT in your calculation. Then they gave you 8,500 without VAT. We are told that 8,500 does not have VAT. So you need to include VAT in your calculation. That means you're going to say multiplied by 1,14. Because the price itself is 100%. Plus the 14% is 114%. Or to make it simple, we can say 8,500 times 14% over 100. Right? The answer that we will get, which is 1,190. So we are going to buy an item which is 8,500 plus 1,190, which will give you 9,690. So the price of the camera is 9,690, but you are going to receive a discount of 8%, which is 8 over 100. So your discount will be 775 Rand and 20 cents. 775.2 rands. That's your discount. In other simple form, you can say 8,500 is the price without VAT multiplied by 114, which is including VAT, 100 plus 14%, which is 114%, multiplied by 8%, which is 8 over 100. It will still give you 775.2 Rand. That's the discount you are going to enjoy if you buy in cash. Last but not least on this segment, we are going to look at the exponent and square root. We need to emphasize also on exponents and square roots. Okay, they gave us a fraction, and that fraction includes exponents and square roots. So we are given 9, right, cube root of 1,000 divided by square root of 64 to the power of 2. Now, when you are dealing with such kind of a scenario, there's a combination of different aspects that you need to look at. So firstly, 9 is independent from the cube root. So in other words, it's as good as 9 times cube root of 1,000. We are looking for a number that will multiply 3 times to give us 1,000. And that number is 10. Divided by Square root and to the power 2 is one and the same thing. It's just the opposite, right? They correspond to each other. In other words, we are saying a square root will cancel with to the power 2. Why? Let me explain why. If you have 2 to the power 2, it gives you 4, right? If you want to go back to 2 from 4, you apply the square root of 4, which is 2. So in other words, if you are applying the exponent and the square root, they are opposing each other. It's a negative and a positive. So a negative and a positive will give you 0. So that's why this will cancel with that. Then you'll be left with 64. Or you can do a long method by calculating 64 to the power 2, and then you look for square root. It will still take you back to 64. Then after that, you remember very well what we mentioned on our previous lesson, that if you want a cube root of 1,000, you will then say 1,000 times to the power 1 over 3. It will give you 10. So hence, when you have 9 times 10 over 64, it will give you 90 over 64. So it can be written as that. So on that note, that marks the end of our lesson today. We will continue with another session next week.